Here's question number 5 on cover your bases. You want to see here, this is a base, so is this. You can see them up here. So we have NH3. So we have NH3. And there's the base right there. And then you have F minus, which has 8 electrons. One extra one, so it's F minus. These are both bases. You throw in the H plus ions. Where do they go? They will tend to go to the strongest base. So you want to compare which is the better base, NH3 or F minus. Should recognize NH3 is the better base. These arrows suggest that. The Ka value of NH4 plus tells you that as well. That's really the best way to know. This very weak acid, 10 to the minus 10 is its Ka value, compared to 10 to the minus 4 for the HF. This is a very weak acid here, which means that it's unlikely to dissociate, which means that the NH3 is a good base. A good base. So when you throw in 100 H plus ions, most of those 100 will bond to the NH3. Some will bond to the F minus. You know, F minus isn't incapable of binding an H plus, but most of the H pluses will go to the NH3. You should see here, all 100 protons went to the F minus, and that's not realistic. The NH3 will take some of the protons. Here, if you look, here we're saying equal numbers. Equal numbers went to the F minus, and equal number went to the NH3. And there is a third base, which is H2O. And so if you think about how does H2O compete with these other two, H2O is a very weak base, not likely to compete. And therefore, choice C is the right one. You can see 10 of the H pluses went to the F minus. 88 H pluses, the lion's share, most of them, bound to NH3. And 2 of the H pluses bound to water. So this is the logical outcome here. You can see there are a total of 100 H pluses, most bound to the strongest base, few bound to the weaker base, very few bound to the pathetically weak base, water.